This is the Amp Hour Podcast, released February 16th, 2020. Episode 480, sponsored by Screaming Circuits. An interview with Ben Krasnow, 8 years on. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Ben Krasnow of Applied Science.
Welcome back, Ben. It's been a couple years.
It has, in fact, 8 apparently.
8 years, yeah. We have watched and marveled from afar as you've made tons of amazing YouTube videos. I think in the meantime, you've actually named your channel, which I don't think it was called Applied Science at the time, but it's been fun to watch from afar.
That is interesting. In fact, if people are curious about kind of like the behind the scenes or how YouTube has changed over 8 years, it actually has changed quite a bit. So might be some interesting things to talk about there.
Yeah, well, yeah. How has that changed? I mean, it's obviously not your full-time job. You have a regular job still. Well, maybe not regular. That's probably you have a interesting full-time job. But how has YouTube itself changed?
But yeah, YouTube back 8 years ago, most of the people on YouTube were doing it just because it was a fun way to spend time. And these days, if someone starts a YouTube channel, they're pretty much thinking about how they're going to, get paid for doing this, basically.
Right. Am I an influencer yet?
Yeah, right. And so there is a lot of that. And there's actually just very few people that put together channels just because they want to. Like most people do consider it sort of an entertainment avenue that they would get paid for. So that's kind of changed the dynamic a bit.
Yeah. Does that change on the like being approached as a creator as well?
Yeah, I've never gone to VidCon, but I think I'll probably break down and have to do it at some point.
Yeah, I mean, this seems kind of fun. There's lots of other personalities there and stuff like that.
Yeah.
And it's run by the Vlogbrothers guys, right? Hank and John
That's
Green.
right.
Yeah, I'm a huge fan of theirs. Yeah. Well, that's cool. And then, I mean, from a reach perspective now too, you have 600,000 plus viewers, so that has to change things as well.
Yeah, it's actually, I always try to cut the balance between doing really niche kind of esoteric stuff and then, generally accessible kind of more sort of general science topics.
Mm-hmm. Yeah.
I think it's a fairly good balance. Like I don't want to abandon the niche stuff because that's kind of what I like the most too.
Yeah.
But then I do get a lot of comments where they're like, I have no idea what you're saying, but I watch it anyway. And I guess that's good too,
Yeah, I think that is great. I mean, like you don't know what you're not gonna like when you're gonna need something, but I've had points where I've recommended to someone like, oh well, Applied Science made a video about this, you should go check it out, and like I wouldn't have had that context to just be like, oh well, you can go and dehydrate caffeine or whatever that thing was, like these just like very kind of weird out there experiments that you run that might actually have application. You never know. It's always going to be like a recommendation engine for someone else, that might help kind of connect the dots.
Yeah, no, it's true. I actually do get messages from folks at research labs or whatever that are very happy to see like a technique actually demonstrated. Like with this latest one with Vanta Black, I don't think there's ever been like a video of someone creating it. And if you're trying to replicate this experiment, just having a video with all the details in it is super helpful.
Yeah, well, and actually that would be a great lead in because one of the things that I really admire about your channel is that you go into patents and you go into papers and you try and replicate these things. And that is definitely like part of the scientific process. And yet I would never think to go into my lab at work and like replicate these, things that are meant to be replicated. It's part of the actual like scientific process. So like, how does that end up impacting your work?
I probably will never do topics of healthcare on my channel just because that's a little too close to work.
Mm-hmm.
And sort of the implicit deal I've always had with Google and now Verily is that if I don't talk about things that are work related, then my channel is my business and I can do with it whatever I want. So as long as we don't get too close to healthcare, that would pretty much be the only topic I wouldn't cover on my channel.
Mm-hmm. Mm-hmm. Yeah, but I mean like the so like the replication of not of your work experience, but I mean of actually like, so you often refer to the patents and the papers that you read that inspire the experiments that you do on your channel, and the replication of actual like the Vanta Black, like you said. So this is a recent video you did. You go and replicate the exact setup and things like that. What inspires you to just go and replicate it in general and not
Oh, I see.
you know what I mean? Like it's I guess I think about it like, oh, I try and make this thing, but I wouldn't think to go and just replicate the same setups like that, and that's a really good starting point.
Actually, yeah, it's easier. It's actually so the challenge is that coming up imagine that you're cooking something in the kitchen to just go total free form without a recipe is actually pretty challenging. And so having
Hmm.
at least a recipe to start with takes a lot of at least it gets the variables narrowed down to a few orders of magnitude as opposed to 10. And so
Ah, yeah.
definitely starting with a paper is more of a just an easy way to at least think, well, at least they got it to work once, hopefully, or you'd think so, hope so, and then you can kind of modify it from there.
Yeah. And so for people, we'll link in the Vanta Black thing. But what is Vanta Black, real quick?
It's the darkest material known to man, and so it looks like you're looking into a black hole. Like, it's actually great for film and photography because if you adjust your camera even normally, it looks like 0 pixels, like they're all zeros. So it looks like you photoshopped a hole in the image when you take a picture of this stuff. And it's actually had a huge, it's been very successful on the internet because it makes for these very like captivating images. But making it requires fairly extensive lab equipment, and that's what I showed in the video.
Yep. 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 Okay, so then let's talk about. So you have this Vanta Black idea, but where are you actually sourcing the papers in the first place? So like, what is it that like made you go and look for that in the first place? Are you just stumbling upon these papers? Are you going out and trying to find them, or how are you sourcing your material?
Yeah, this is an interesting one. So Vanta Black has been kind of on the scene for like a few years, and the thing that initially made me want to do it is that there's this agreement between the makers of Vanta Black and an artist, and they gave him an exclusive license to use their Vanta Black paint in his art exhibits. And there was like this big deal in the art community, like no one else could have the paint except for this one guy.
Huh.
And it was very controversial. It's kind of stupid, of course, but it's funny because like no one else can have like the blackest black. Like only this one artist was entitled to use it. So there was a lot of pushback and everything. And I thought, I'll show people how to make it in their own garage if they have dedicated enough time and lab equipment. So that was kind of the original sort of inspiration. And then in the meantime, these researchers at MIT released this sort of easier process even, and they claimed it was even blacker than Vanta Black, which we still don't really know, but that was the claim.
Yeah.
I think I found it on just popular media even, like it came up in a hacker news feed or something.
Okay. Yeah. 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 That and that sounds likely. So you read that, and I read that, and I go, oh, that's interesting. Look, they're being kind of buttheads about like not giving this thing away, and you go and you look at it, you're like, no, I could do that.
Oh, absolutely. Oh, that was a great lead in. I was like, oh, this is perfect.
Yeah. Yeah. And then you said on the video too that like it is tough to measure as well, and so that's like another interesting thing that I've noticed about your replication of experiments and stuff is that it's tough to replicate everything exactly the same or how it's published as well. Like some of the ins and outs of how things are published kind of can make it tough to completely replicate at home.
Yeah, for sure. It's nice to have a large technical viewer base. And so in this case, the person who actually published the paper at NIST that measured all these different Vanta Black materials emailed me and said, well, if you'd like me to explain how I built the measuring sphere that we used in that paper, I'll send it to you.
Oh my god. Yeah, that's great. Yeah, because it probably gets passed around, right?
Yeah, and I linked to his paper and everything, and he gave me the details of how they built that measuring sphere. So yeah, it helps to have like a lot of technical people watching. Also, it's a little bit nerve wracking because every single mistake will be discovered within an hour or two of it being posted. So,
Right, right. Yeah, I mean that is kind of the problem with the focus of so many eyeballs is does it end up impacting you? Like, do you think twice about like hitting the publish button or anything, or are you just kept pretty steady?
a little bit. I mean, I like to be correct and everything, and so what I've found is that it's usually better to not uh, guess. Like if I basically I don't like script my stuff, and so every single thing I've ever said on YouTube is unscripted.
Hmm.
And then if you're talking to someone like we are in conversation, I might say something that's not perfectly correct just because we're just talking.
Right.
But that starts to not fly so well when you have a big enough channel where people kind of expect it to be almost like reference material as opposed to just chatting.
Right. Yeah, it's like when does that cross over from one to the other? And it's and then it's also there for not all time, but you've got 10
Well, it
years.
pretty much
Yeah,
is.
10 years
No,
of
I still
material.
get people correcting. No, definitely mistakes even from years ago. I'm still getting corrected on. So yeah, I've learned to basically be a little bit more tight-lipped in the talking. Like
Yeah.
if there's an uncertainty, maybe cut that out or
Yeah,
something.
it's kind of unfortunate, like, because that's gotta it's gotta kind of harsh your vibe a little bit.
It, some people script. I mean, that's what a lot of people tend to do. But
Yeah,
I think it just comes off better if unscripted.
yeah,
So
yeah, definitely. That's great. I mean, and so okay, well, let's give a little more historical context since the last time you've been on the show, at least, which was episode 75, if people don't know. So Ben was one of our first guests. I think it was like you and Jerry Ellsworth and Alan Yates and like a bunch of other people that ended up all being, and Jeff Kaiser, and like you ended up all being coworkers. So what have you been up
that's
to
right.
since 2011, Ben?
Yeah, so yeah, 2011. So, and I think we were talking, it may have been before I started at Valve. So in 2011 or end of 2011, I started working at Valve. And that was the joke around the office was that to work there, to work at Valve Hardware, you had to be on the amp hour, which was 100% true for like half a year, I
That's
think, or
great.
something
Yeah.
like that. Or maybe,
Yeah, we
yeah.
kept saying we were going to charge either Gabe or Jerry, for recruiting everyone, but we never got any royalties. So, although I did end up doing some contract work there, so that I guess that paid itself off at some point. Yeah,
Oh,
yeah,
there you go.
yeah,
Okay.
yeah.
And it completed the prophecy that you had to be at least somehow involved with the
There
amp
you
hour,
go.
let
There you
alone
go.
on the show, maybe running the show. Yeah.
Yeah.
So yeah, so I was at Valve for a while, and then in 2014 left and joined Google X.
Mm,
And when I joined there, they wouldn't tell me what I'd be working on. It was a total mystery. They were back in the super secrecy days, but it turned out to be healthcare projects, and that continued on to be a separate spin-out company called Verily,
hmm.
which is a majority-owned subsidiary company of Alphabet, and that's where I am now.
Wow. How did that conversation go? Like, who when they were like calling to recruit you to like Google X? I mean, obviously they have Google in the name, so that's something. But like, not telling you anything you're working on? Like, how did that go?
Yeah, it was pretty annoying. They even had like a non-disclosure agreement, which I signed. And then I said, okay, well, now tell me what I'll be working on. And they said, oh, no, no, we still don't tell anything. This one is, they told me that this was like the ultra confidential project, that even like the regular confidential ones were,
Wow.
that was soft limits.
Double secret probation.
Yeah, exactly. And so, I had a feeling it might be Google Glass or self-driving cars, which were kind of the only public projects back
Right,
then.
right.
But it turned out to be healthcare. So I've actually had the same role and the same group the entire time I've been there.
Yeah, you said this is one of your longest running gigs, so that's
Yeah, I've
new.
been there close to 6 years,
Wow.
and that is longer than I've worked for anyone, including myself,
Yeah.
actually.
Yeah, that's pretty crazy, and particularly crazy in like, large Fang, Faang. Although I think it's not no longer Fang. It'd be what, Fana, because it's Alphabet instead of Google.
Oh, right.
But like a lot of people move in and out of those large tech companies, and also it's just Silicon Valley, so like there's just a lot of movement. So how has that been with being there for 6 years?
It's pretty good. I mean, it's also like seeing a company grow up. So I mean, Google X has always been big, but the healthcare effort within it has been much, much smaller. So when I joined, essentially the science team or whatever, the science part of the healthcare aspect was only 20 people,
Mhm.
and now it's about 1,000. And
Oh
so
wow.
it's been, yeah, so it's been fun to sort of be part of that growth, and it does feel like kind of growing up with a startup in a lot of ways.
Right, without the crash and burn likelihood rather. I,
Yeah, I'd like to hope so. Yeah.
I mean, just having a big parent company behind you is, helpful from a, funding perspective and everything. It totally could still flame out, but it's less likely to run out of money, which is sometimes just the problem there. So that's great.
Yeah, of course.
So okay, so you signed this super secret, double secret NDA, but you are talking to me here, so there are some things you're allowed to talk about now.
Oh yeah, yeah. No, so after we detached from Google, we weren't secret anymore. I
Okay,
mean,
got it.
it was out in the open.
Right, right.
Alphabet has this, health tech company, and we talk about what we're doing all the time, and a lot of the projects, not all of them, but a lot of the projects are public.
Okay.
And
That's true, and I guess
even
you've
Google
you've you've
X,
been on Embedded twice, I think, since you've been on the Amp Hour, and I think you've talked to some of it about on there as well.
yeah. So it's much less, and even Google X gave up a little bit of the secrecy angle. I mean, they still have non-public projects too, of
Sure.
course, but I think they realized that this like total, black curtain doesn't really benefit as much as people think.
Right, right. Okay, so I mean, what are some of these projects you've been working on? I mean, what again, whatever you're allowed to talk about. I wouldn't have thought of Google X or Google in general doing healthcare stuff, but at the same time, there's software and everything, and Google's a big software company, so it's kind of makes sense. They like the data piece, right?
Yeah, it's a good point. So it's true that the sort of the information part of healthcare is a spot where Google would have a lot of contribution, but also the hardware itself and a lot of the actual like tech innovation in health is part of our jurisdiction too. One of my favorite projects is this accommodating contact lens, which is public. Every person, if you live long enough, gets presbyopia. You can't read the newspaper when you get to be over the age of 40 or 50 because eyes just eyes just get old and they don't focus close anymore.
Hmm.
So everyone uses reading glasses. But we've been working on a contact lens that actually changes focal length automatically for you. So when you look up from the newspaper, it focuses far, and when you look down at the newspaper, it focuses near, and basically makes your presbyopia go away, which is really awesome. And it's a cool technical project. It has to have, a battery and a microcontroller and a focal length changing optic all inside a contact lens.
Wait, there's a battery in there?
Yeah,
Oh, wow. Okay.
yeah, I know. It's a full on piece of electronics in a semi disposable contact lens.
That is intense. Yeah. And well, I guess we should also refer people to I think the video you had just done when you were last in the Amp Hour, which was an LED in a contact lens. Was that part of your recruiting effort or being recruited rather?
No, it's hilarious how that turned out. And so no, at the time I was kind of making fun of these of these augmented reality researchers at UW, who actually I think I ended up working with in kind of a weird way. But
Yeah.
they, there was another one of these pop media articles about, oh my God, researchers put an LED in a contact lens. This is like the beginning of AR displays in a contact lens. And I was trying to point out that putting an LED in and lighting it up is actually not too hard. The hard part is, the optics and the bandwidth and the throughput and the image forming and all that sort of
And
stuff.
also watching Ben put a contact into his eye that was not meant for an eyeball. That was the hardest part for me. That was very rough to watch.
No, that was a pretty hilarious video, and it did have kind of the intended effect where people were flipping out, and I was a little bit more provocative maybe in those days, and so I was just putting the video at it.
Anyway, so okay, so you worked on the real thing though, so that's interesting as a historical perspective. But how do you get these micro scales that you're doing? Like, what were some of the technologies that you had to create or work with that made this possible?
Yeah, I have to admit, I actually haven't worked on the accommodating lens myself
Oh, okay,
personally,
that's
even
fair.
though I'm pretty well aware of it. But yeah, we actually have a microfab and everything on site, so we can do a lot of wire bonding and sort of chip scale type processes. Not a foundry, but the microfab for doing all the support type structures. And that's pretty handy to have on site. We also have like injection molding machines and diamond turn machines on site to do all the optics, and that's kind of a key part when you're doing these really advanced custom optics projects.
Yeah. Hmm. Okay. So, what were some of the things that you were working on then outside of the? I mean, if it's not the contact lens.
Well, unfortunately, so I work for the super secret confidential lab.
Interview
I know.
over.
So
It's
no,
all done.
actually, no, it is fun because so I have the job of prototyping all of like the yet to be disclosed type
Hmm.
things, which is fun because I get to work on the latest type stuff.
Mm,
But it does mean that all of my projects are the undisclosed ones that haven't
I
actually
see.
hit the ground just yet.
Got it. Got it. Okay. Well, let's talk a little bit about process then, because one thing that's interesting to me is the fact that you're doing, large, you're doing research and kind of seems like fundamental research. I mean, I listened to the embedded episodes about your time at Valve as well, and it seems like you're always kind of like trying out these things. You're trying a lot of different things, and then you're kind of packaging it up and getting it to a working state. But what is that like inside of large companies? I mean, do you have complete freedom, or what is it? What does your lab look like? As much as you're allowed to say.
Yeah, no, that's a good way of approaching it. My lab looks kind of like my shop you can see in the YouTube videos.
Hmm.
Like it's mostly electronics with some 3D printing and actually a little bit of chemistry.
Okay.
Um, and it's pretty, we gave up our desks. So we made a deal with the CEO early on that we gave up our desks to get a little bit more lab space. So I live in the lab 100% time and don't have a desk outside.
Yeah, that's good too, because then there's access control. What's that? What's that management pipe? I can't hear you. You're on the other side of that locked door. I don't know what you're saying.
Yeah, right, exactly. And so as long as I can have a cup of coffee at my workstation, that's basically, as much as I
Yeah,
need there.
exactly. Yep. Yep. Okay.
And so, yeah, the process of innovation, we basically are trusted to come up with stuff that's going to be good for the company. So taking into account sort of the scale at which we need to execute things and sort of the impact that it needs to have in healthcare, and then all the inputs, like how much possible, how much of this is an engineering project and how much of it is sort of a scientific guess, basically.
Yeah.
Kind of put these things all into a blender and come up with an idea that sort of ticks all the boxes.
Yeah. I mean, it sounds kind of, to use a oft quoted but maybe not super accurate thing, it kind of sounds like the Bell Labs model of like there is some fundamental research, but then it's very targeted at getting out to a commercial product. Is that a fair assumption?
Oh yeah, yeah, absolutely. Even within Verily, we have like a separate science team that's focused a little bit more on fundamental questions as opposed to taking engineering and making a product. And we try to blend together and stuff and come up with things that are kind of right on the edge, which is probably the most valuable space in which to innovate.
Totally. And okay, so now you're working on a project. We should probably come up with a fake project we can keep using as an example here. Let's see. Robotic finger. That's what we're going to go with today. So you're making a
Okay.
new robotic finger. Chris was cutting some vegetables. He chopped off his pinky. He now needs a robotic finger. You've come to the edge of research. Like, what do you do then? Like you can't Google for anything else. You can't find anything else that's out there. Like, what steps do you start taking when you run into that wall?
Yeah, it's really a good question, and I think probably some of the most successful things, the most successful tech products are sort of recombinations of existing things that have just come into reality.
Okay.
So, like for example, the iPhone is this hugely successful product, and it didn't involve any brand new tech. It's not like they came out with a new kind of display or a holographic thing or a weird way to use the phone. It was literally just a phone with a really nice display, a huge touchscreen display, and a connected app store. That was kind of like the ingredients that
Yeah.
made that thing as popular as it is. And so, similarly, for like a robot finger type thing, it would be like taking existing innovations that are really new and people haven't had time to play with them yet and putting them together into a
Mm.
product. So, something like brushless motor control plus maybe an algorithm that allows the finger to work better some way,
Yeah.
some piece of software that makes it more useful, that sort of
Yeah, like
thing.
new haptics, something from a smartphone. Okay, so then you start casting about and you're trying to find these new pieces of tech. Like how do you brainstorm what's out there?
It's a lot of internet searching and stuff.
Mhm.
I admit that without Google we'd all be
Well, of
without a
course.
job basically. Like, or I shouldn't say. I mean, any old search engine is what I mean. But without the internet and people basically posting stuff, it wouldn't work.
Yeah,
Like without that sort of information hose, everything would dry out.
right.
And some of it's personal experience. I mean, we talk to people and go around and know kind of what's newly available and that sort of
Okay.
thing.
Yeah, that's good. It makes sense. I mean, it's just, kind of a question of how does inspiration strike, I guess, which is like, I don't know. Yeah. Sometimes I'm taking a shower, or sometimes, like there's a thousand ways it could happen. I'm just wondering if there's anything specific. I'm trying to just extract your magic formula, Ben, and sell it to users of the Amp Hour.
Well, okay, so here's another key thing. Like, if I say that successful tech products are combinations of things that already exist but haven't been put together in the way, the real challenge is, do you think more about what you can do with combinations of cool tech, or do you think more about like the problem space?
Yeah.
Like one thing that innovators often forget is that you could come up with something that's really amazing and is a combination of currently available tech, but no one might want
Right.
it.
Right.
And so figuring out what is hard enough to build that no one's done it yet, but also something that people really need. That's the
Right.
really, really challenging
Right.
intersection.
Well, yeah, exactly. It's like you're internally like, okay, we've created this robotic finger. It's great. It's amazing. It's super tactile. It does all these things. And our total market is everyone in the world. Everyone could use a sixth finger. It's like, whoa, what? What?
That would definitely be a pivot.
Yeah.
If you started off doing a prosthesis, you could say, well, actually, maybe people need an extra finger. That would be a classic pivot at the 11th
Why
hour.
why not a finger on your forehead? Like you never
Yeah,
know.
put them
Yeah.
everywhere. Yeah.
It's you know, primates, they started to evolve when they had thumbs, or they evolved to have thumbs, and look at what happened with them. What if there was a second thumb?
I like this. Actually, yeah, that's yeah.
We'll market it after this episode's over. Well, so you keep saying we. So how many how many Ben Krasnows are there? Did you clone yourself?
No, no. I
Okay.
I work in a small team. It's just three people,
Okay.
in fact, and so we're like the skunk works
No, that's
department
great.
there, and so we come up with yeah.
Yeah. Have you read that book, Dave? Last week, I mentioned it to Dave. He still hasn't read it. Have you read Skunk Works?
I have
Oh,
not,
you gotta
but I've
read it.
used the term like
It's
forever, so I
so
think
good.
I
It's
have
so
to.
good. Listen to the
Yeah.
audiobook. Fantastic. I love it. Yeah.
Okay, I will.
I think the only thing that's different in terms of like methodology is that they just had a shit ton more people. Like there were so many people on the Skunkworks teams, but it was just crazy how the kind of things they came up with too. Then okay, so now you've made a robotic finger or similar. Why would you be making it in the first place? Would you be the one that's like, oh, well, maybe there's a market for a robotic finger, or is it like someone has come to you and be like, well, there's a thing, So you mentioned problem space. Like, who's is that a push or a pull? Like, are you finding it, or is someone else finding it and telling you about it?
Yeah, and this is the thing about healthcare too. So, first of all, it can go both ways. Like we occasionally have people like the CEO that will tell us, okay, we need to do something in this space, or I needed to see something like this. And also times it's just us spitballing and we come up with it completely on our own. So that can work both
Okay,
ways.
yeah,
But in either case, healthcare is just horribly distorted. Like healthcare is bad because no one pays. There are no customers in healthcare basically. Like if you're sick, you don't want to be sick, and you also don't want to pay to get better. You expect basically your insurance to take care of it, or most people do.
right. And we should say this is a U.S. centric view as well, but there are other problems in other countries as well.
Yeah, so it is true that Verily is worldwide, and we do have offices outside the U.S., but our primary focus is the U.S. at least for now. I
Yeah.
mean, it's most of the company. And most of the real problems are in fact here because the system is so screwed
Oh,
up. And so yeah,
yeah.
it's if you want to fix healthcare, you may as well start here. Basically,
Yeah,
is what I'm
right.
saying.
You want a problem space? We found one.
Yeah, it's 20% of the entire
Oh my
economy,
god.
and it's also a hugely inefficient thing. And the reason is that the incentive structure makes it such that everyone wants to waste as much money as possible because it's so lucrative, right?
Oh, well, that's an interesting space to be in. Okay.
Yeah, and it's so basically, if you do traditional startup development, it's sort of like, okay, find, your first customers, give them your early product, see if they like it or not, start figuring out. But that doesn't really work so well in healthcare because the people using your product aren't the ones paying for it, and the ones paying for it don't even care how expensive it is because they pass their costs on to someone else. And
Ooh.
so it's a very distorted market that has very different requirements for coming up with what a good product is.
Okay. And so who would ultimately make that decision then? Is it like, or does that not even matter to you? Maybe that's another possibility. As someone who's making the technology, is it like you make a bunch of things and then someone has to figure out if it's a viable product?
No, for better or worse, we actually have to do some of that too.
Okay. I mean, I think personally, I would think that like you want to make something that's actually useful, actually like is going to make it out there, right? So that makes a ton of sense to me.
Right.
But like you said, it's a kind of convoluted system, so I don't know.
Yeah, so no, so we have to do it, and so that's actually part of the innovation. So being sort of a an inventor type person in healthcare means basically inventing in sort of the economic space of what all these things do. Like that is in fact a big part of the innovation is figuring out how to navigate this really tortuous kind of economic model.
So like I've read a lot of innovation books. I've marginally been involved in innovation in an engineering sense, but like who do you end up talking to go and find that space, problem space, and is it like doctors or who are you talking to?
We sometimes go outside for that kind of thing, and we also have physicians that work at Verily.
Oh, okay,
Also,
yeah.
the former head of the FDA also works at Verily
Oh
now,
wow.
so we do have a lot of insight into yeah. So no, we're pretty serious about engaging the existing system and being aware of what's going on and everything. So talking to people internally is probably the most common thing, and sometimes we go outside
Yeah.
too.
Okay. How much iteration is there then? Okay, so I mentioned an end product that you've already decided you're gonna make a robotic finger. How often does it like you're just like straight to it, or how many times is it like, well, we're gonna try a robotic toe and a robotic eyebrow and a robotic all these different things, and eventually you end up on finger.
Yeah, that's a good question. In a sort of more traditional startup, you would want to iterate sort of almost like random walk out from your
Yeah.
idea. So if you think you have something good, you'd probably try nearby hits next, kind of spiral outward to see kind of where there's a rich target. For the way that we work there, it's almost better to do a broad scan. So we try to make a hit and it turns out to be a miss or something, instead of spiraling outward to find something nearby, what's worked for us better, and I think maybe serves the purpose better of us being the skunkworks, is to actually go completely different,
Oh, really? Yeah.
to go in a completely different direction and try to cover as much space as possible in a short amount of time, and assume that there is not a target. If you have a miss, assume that it's a better idea to just shoot somewhere else as opposed to like spiral out nearby.
Yeah, because it's going to be like there's at least going to be enough of a spark when you do find something that's worth doing a deep dive or taking all the way to production kind of thing.
I think so. And as you say, the dynamic is different. If you're at a funded place and you're in a skunkworks, it's a slightly different set of requirements than if you're in a startup and you're sort of purpose built.
You're just trying to survive in that case, right? Like, just I'll make anything.
Pretty much. And like your investors kind of expect you to do the thing that you said you were going to do. So if you're pivoting, that's cool, but you can't like go completely into left field. But in our case, it actually makes sort of more sense because we're sort of early. We're almost in the stage before you have a startup and one investor. Like we're sort of pre at that level,
Yeah,
basically,
yeah.
I think.
I guess that's a good lead into like how far do you take it then? Like, so you make a is this like a show it to an internal team? Is it make 10 of them, make 100 of them, make 1,000 of them? How many? What is the output of your group and like what you end up making?
Yeah, we've made hundreds. That's as high as we've gone, enough to show basically technical reliability. So usually the question is, I don't think it's going to work. That's usually the first complaint or whatever, which is great because that means we're coming up with something that's so technically good that people, first think, well, it's not going to work. So then if you build 100 of them and show a reliability curve, it's like, okay, they work. So that question's over. And then the next question is, well, I don't think it's going to work in the market. I think it works technically, but it's not going to work economically or something. And that's a much more like gory
Yeah.
question. Obviously, to prove that it works economically would mean it's a fully completed product. So the next step is to basically try to build evidence showing that this thing could actually be a real product and survive in the healthcare market. And that's challenging. That's really
Yeah.
tough. It makes the technical stuff look like, like if a day is your whole product cycle, the first like 10 or 20 minutes is basically the technicals and the rest of the day is figuring out like the economics of how to like make it into a product
Right, right,
basically.
right, right. And I mean, then I assume some of the things you've done have made it all the way out. I mean, how much does it look like the thing that you've output by the time it makes it to the actual market?
Sometimes it can be pretty close, actually. Like Verily's model is to always partner with other hardware manufacturers so that they end up being the manufacturer of record. And so, in a lot of times, they actually don't. We don't get our name out there, so it's not good for vanity people because there are products out there now that Verily engineers have worked on, but it has nothing to do with Verily. Like the partner usually takes the name and the marketing and everything else.
Interesting. So how does Verily make money then?
Oh, they pay us. I mean,
So it's like a licensing.
yeah,
Okay,
basically,
that
yeah.
makes sense.
But a lot of times it does stay pretty close to the original concept prototype, even in a lot of cases.
So it sounds like you're almost like you're making like a dev kit that someone can be like, I've seen a couple dev kits that look very similar to the end products. uh,
Yeah,
uh,
yeah,
yeah.
actually, yeah.
So, are you allowed to say anything that you've worked on in the past or no?
Unfortunately, I don't think so.
All right. So, well, folks, if you're sick at some point and you've got a robotic finger, you may thank Ben Krasnow, or not.
Yeah, if it doesn't work, just don't mention it. It's
Have you? Oh, I guess this is the question then. So, has anyone ever asked you to do something on the Applied Science channel that you've ended up having worked on?
no. I mean, but if people suggest anything that's like bio or healthcare, I'll tell them that it's off limits. Like
Yeah.
that's the one thing we can't touch on the channel.
Well, that's fair. That's fair. Well, it sounds like a playground. I mean, what kind of gear do you have? I mean, do you have like specialized gear, or like, I'm imagining like a mad scientist lab, but it sounds like it's just a lab.
Actually, we are one of the biggest tour stops on in the campus
Mm.
there. So when they bring folks through it, we do have quite a few really good demos. One of them, I think I can get away with this. One of our products actually uses a combustion as its source of
Oh,
energy, and so we use we use a tiny amount of nitrocellulose, and it's like magician's flash paper, and so the actual device uses a teeny tiny amount, like 200 micrograms of this stuff. It's when you set it off, it doesn't even make it doesn't look like anything
yeah,
happened.
right.
that doesn't even make a pop. Like it literally just disappears. But to show it off for the demos, we burn, a couple of grams of this stuff, and it makes this big fireball and
Right,
everything.
right.
It's a good
Yeah,
demo,
that's great.
and it actually has a real use in the product because compared to lithium batteries, even the energy and power density of nitrocellulose is like thousands of times higher.
Interesting. Yeah. That's cool. I mean, I can't imagine how to capture all that stuff, but that's probably part of the magic, right?
Yeah. It's basically like a little motor, and so if you burn this thing, the expansion of it is what drives a process
Got
for
it.
us.
That's really cool. That's actually a good lead in. You do a lot of chemistry, like a lot of chemistry. Were you doing that when we last talked?
Probably not quite as much as now. I don't know. I've always liked chemistry, but it is true in my current role. Being on the bio side, like fluids and chemicals and stuff just crop up more
Yeah.
often.
I mean, your background was mechanical, and obviously you do electrical and chemical and all this other stuff. So, what was the lead in? Because I feel like everything's kind of moving towards the biological realm, anyways. So, like, how did you start kind of ticking into that world more?
I mean, yeah, it's the old internet basically. So everything I've learned about chemistry came from the internet. So for better or worse. But yeah, it's I don't know. I mean, chemistry is fun, right? Like everyone loves mixing things together and exploding nitrocellulose and stuff. I mean, it's a very like attractive kind of
I'm
field, I
mostly just
think.
scared of it. You know what I mean? Like I would look at your home setup and on your channel, and it seems like everything's kind of quite dangerous. And I think it's just that's just I'm clueless about it, right? So that it seems dangerous, but maybe it's not. And I wouldn't even know where to start for that kind of thing. You know?
It's true. No, there's definitely, actually, safety is an interesting topic that comes up, on the YouTube channel a lot
Hmm.
too, where YouTube creators traditionally have this like annoyance with safety commentators. And back in the day, Matthias Wandel, this woodworking guy, he'd say, "Okay, if you post a comment that has anything to do with safety on my channel, I just ban you immediately." And I mean, he was maybe a little bit more sensitive than I am, even, but it's still the same thing where people are like, "Are you sure this is safe or
Right,
whatever?"
right.
And it's like, well, I don't know. So in my last video, there was definitely not safe stuff going on. I mean, I was basically feeding acetylene and hydrogen into a glass tube that was like red hot in a
Yeah, yeah,
furnace, and
yeah.
it's like, well, it's pretty obviously what could happen there. And so I don't know. I always say, life is unsafe. I mean, I always say I take safety precautions. I don't really think of myself as a careless or a reckless person, but yeah, there's always an element of, certainly there's more risk than doing circuit boards, let's
Sure,
say.
sure. Right. But we also cross the street every day, get into cars, lots of other dangerous things, I guess. That's where the precautions come in. So that's good.
That's what I always bring up too. Like people, the more like weird and gruesome the possibility of the accident, the more that people focus
Mhm.
on it. And so it's like radiation, X-rays, chemical reactions, like poisons that get inside you without you knowing it.
Mm.
Those like really freak people out. But yeah, when you step across the street, your chances of getting flattened are like, way
Yeah, yeah,
higher.
definitely. Oh, yeah. So, I mean, on the chemistry side of things, though, so what are some resources, I guess, that you look at online? I mean, like, are you? I think about it, and I think of like redox equations, which you kind of cover sometimes on your channel, and it's in a very practical way. But it's like the channel's called, it's applied science, right? So, like, what is the threshold for like starting to just kind of hit the chemistry and actually mix things together? I guess.
Yeah. I always like to be like application driven. So a lot of people, and this is why I think university is totally upside down. Like when you show up at university, they just start giving you the fundamentals without any like background of why you would ever need this stuff, which is totally, totally the upside down way to
Hmm.
learn. It's much better to have a problem and you just get into it and trying to solve that problem. And along the way, you'll learn things that are
Hmm.
useful. And that's how you know that the stuff was useful because you needed it.
Yeah, of course, of course.
So yeah, right. So I think if you have like a problem that could be solved with chemistry, like for example, this energy storage problem we had, it's like, okay, lithium ion is great, but it's still not powerful enough and energy dense enough for this problem. So what do we
Mm.
do? And then you start investigating other stuff. Well, what are other energetic materials that we could use? Combustion is one way. How do you harness it? What kind of combustion? Are we talking detonation? Does it just burn quickly? I mean, there's all these other things that'll come up. But if you know your goal is to basically make a cheap, small energy storage system, then you kind of have parameters to start like looking
Yeah.
into.
Yeah, that's great. I mean, and that's a really good example too. It's like you basically are running up into a wall of limitations, and then that's when you start to kind of cast about and find, you know, whatever tools you need for that, and that's kind of more the just-in-time learning kind of concept of it all, right?
Yeah, I like that phrase. Yeah, it's just in time learning, which I think should be like the main way of doing it. And like the fundamentals ground up approach has at least never worked for me. Maybe it works for other people.
So I've thought about this a lot, and I've talked about it on some conference talks I've given too. And the thing that I always wonder about is like how much background the push and pull of it all is like how much background information do you really need, right? So like just in time is good, and I think for someone at your level and maybe my level as well, like it's good and it's like okay to go dig into a redox equation at that point. But if you're like, why does it say H plus? Like I don't know how much baseline knowledge you need. You know what I mean? Like how deep the rabbit hole goes if you don't have that underlying knowledge.
Yeah, it's a good point. At the level of like H plus, okay, yeah, maybe that should be sort of background learning, and you can learn that without needing necessarily a
Yeah.
task. There's sort of like this other layer where it's like one up from that, where you might see like the phrase Lewis base in one of these chemistry
Uh huh.
papers. And then it starts to get harder because that's definitely something that would not be taught to sort of like that wouldn't be that if you have a chemistry major, you'd know what it is. But if you're some other kind of major, you probably wouldn't be taught that in university anyway. And then it's hard to find out what it is because everyone who only talks about the structure of Lewis bases are already pretty well acquainted. Like there's this like middle layer where it's like very hard to access background
Right.
information.
It's like the I mean, like I've talked about already, it's like what do you Google for? And in that case it's even hard to Google for that stuff because you don't know what the search parameters are around that thing or then finding good
Yeah,
resources.
exactly.
Yeah.
Well, it gets esoteric. I mean, of course, there's a Wikipedia article for it, but if you read it, it's not helpful because it's only written for chemists and other people that are pretty well acquainted with the
Yes.
topic. And
Yes.
so
Yeah, I've had some contextual electronics students that are like, "Well, we were using an op amp, and I went and read an op amp wiki page, and now I'm like, I've been here for 16 hours, and I don't know anything that's going on." It's like, okay, whoa, let's take a step back. And sometimes it's like you just gotta go and find something to follow along and try it. And it almost sounds like that's what the some of the papers that you're doing as well. Like that's kind of the forming the context for what you're building out. Is that fair?
yeah, I think the op amp example is perfect too because op amps don't work anything like they describe in undergraduate college courses. Like not even close. Like you should just forget all that stuff. It doesn't make any difference. Op amps are so far from. If you had a perfect op amp, obviously we'd all be out of a job because the whole point of electrical engineering is figuring out how to work around
Yeah.
limitations, essentially in op
Right,
amps, right?
right.
And so
That's great, that's great. Everything would be an analog computer
I
and,
hated it.
be fine.
Oh yeah, I felt cheated because it's like you read even on Wikipedia how an op amp works and you feel like okay I understand it now and then you go try to implement it and you'll be I mean you're sunk. I mean there's so many imperfections that it's not
Yeah,
even
yeah,
close.
that's the fun of analog. Well, to jump over to electronics real quick, you are a KiCad user, and I was very happy about that. I've told
Yeah.
people about that. How did that get all started?
Yeah, I love CAD. In fact, it was an easier transition than I thought. So I guess let's see. I started off with Altium actually, I guess in the early days, just because why did we pick Altium? Maybe it was because it was Jeff's favorite.
No, because I remember Jeff learned it when he came to Valve. So someone else, I think maybe Jerry did. Someone, you're talking about at Valve, right? I remember Jeff
Yeah,
saying, "I
yeah.
have to learn Altium now." I think he had learned other things, so
Huh.
maybe nobody picked it.
I don't even know who's
Alan's from Australia, so maybe it was him. That's an Australian company.
no.
Altium is so.
Huh. Okay, maybe it was. I can't remember anyway, but I was on Altium and then I actually switched to Eagle for a while. One of the other Google X guys was a big Eagle fan. And to make it easier to switch files and
Hmm.
stuff, I was using Eagle. And then it was actually when they went to the subscription model that I decided to give KiCad a look and was totally blown away by how polished it was. I was expecting something kind of, half baked, but it's actually very serviceable. In fact, some of the features are even better than an Altium at
Oh,
this
really?
point.
Wow. Okay.
Like the push and shove routing is one thing that people really love. You can drag your traces around and it keeps the design rules intact in real time as you're dragging and you're like, wow, this just works
I had a
perfectly.
moment where I was using it a couple days ago, and I was like, I actually don't remember a time before this. I don't know if I could ever go back because it'd be real bad. So
Yeah, and a cross platform and open source. I mean everything about it's pretty
yeah.
fantastic.
Well, great. You should come to KaiCon 2020 now. It's in CERN.
Oh
So
yeah,
I'm sure
yeah.
that you could just go and like pop into the Atlas and, show them a couple things and so you should do
Yeah.
that. Yeah, that's great. What other kind of tools, I mean, are in your Ben Krasnow toolbox? Like, what else? I mean, machining seems like a really big piece of what you're doing on applied science, maybe at work too. I'm not sure.
Yeah, we're actually physically right next to the machine
Mm,
shop in at the Verily campus. And so we occasionally get their help with stuff. We have two Haas mills and actually a big 5-axis Okuma in there too. So we're pretty on machines. The Form Labs printer has actually been the biggest game changer piece of equipment that we got in the last year or
yeah,
two.
that's the SLA just for high resolution stuff.
Yeah, and they cost about $3,000, which is very cheap compared to what the usage of the things that come out of them. So, if, Proto Labs makes high resolution 3D printed parts, and we used to have like a monthly basically open tab with Proto Labs, and then since buying these Form Labs printers, we just stopped
Oh
using
wow,
Proto Labs
wow.
completely.
Yeah, and then it's like right there. You just set it before you go home. You come back in, and it's effectively good to go, and that kind of thing. That's nice.
The resolution is fantastic, and the material properties are good enough. They're not perfect. It's not like a piece of ABS plastic, but it's good enough where you can basically make functional parts with I'd say what 50 micron resolution. It's pretty
Yeah, yeah.
fantastic.
Well, and so I mean, it seems like kind of CAD is so now you're in a world where fabrication is not easy, but it's simplified. So is it like your CAD skills kind of have to up to match your the needs of your projects and stuff?
Yeah, I've always been kind of okay at CAD. Like we use SolidWorks at work just because it's already set up kind of in the Google like big
Oh yeah,
licensing
yeah,
system and
yeah,
everything. But I would definitely at home I use Fusion 360 and recommend that for people that are doing small businesses or
yeah.
anything else.
I like that one as well. It's good. We're trying a new thing on the Amp Hour where we've asked our sponsors to teach our audience. This is a really important thing for us. Today, Dwayne Benson from Screaming Circuits is going to talk about an old pick and place machine and how that impacts their customers.
Even though most of our business is deals with the newer componentry, we do have some legacy customers, and we've held some equipment around to service with that. The machine is it's called an automated sequencing and insertion machine, the VCD from Universal Instruments.
I've actually had the opportunity to tour Screaming Circuits in person, and we'll hear more about that in the future, but this machine was just the first thing I wanted the Amp Hour audience to hear about. It's this huge piece of machinery, it's heavy, it's metal, and it looks dangerous and awesome.
Well, it sounds a bit like a train engine going through when we're running it. It's big and blue. The sequencer component of it probably 15 feet long, and it has these room for these big through-hole reels. And yes, through-hole components used to come on reels as well. And it takes all of these things, it clips them out, and puts them in a new tape that is ordered based on when the components will be put in the board, not based on what components not based on what the component is. So then you come up with you end up with a second reel, or final reel there. You end up with a reel that has all of these components in sequence. You put that into the through-hole insertion machine, takes that tape, and it cuts out the components, bends the leads, sticks them in the through-hole board, trims the leads, and then bends them a little bit so the parts don't fall out, and gets it all ready to go into a wave solder machine.
And so my next inevitable question, and maybe yours too, is who's using this thing? Who actually needs a through-hole pick-and-place machine in 2020 with all of the great equipment that's literally sitting 20 feet away on the Screaming Circuits manufacturing floor?
We still have two customers who have been with us for decades, or with our parent company, Milwaukee Electronics, for decades, and we still use this largely for their jobs. It's one of the contrasts of modern manufacturing in most cases, where you sort of leave the old behind. In this particular case, we don't. We carry it with us. Those customers who've been with us for so long, they have a decision to make every year whether they should redesign their board or just keep using it as is. And some of this is going to some really, really harsh environment equipment. And it has made more sense for them to keep building the same thing than to redesign it. But when someone's known you for 20, 30 years and has trusted you for that long and continues to trust you for that long, that's a real important statement, and it's something that we strive for with all of the folks that we do business with. We don't want to just put parts on boards. We want a relationship.
So no matter what type of technology you're working on, Screaming Circuits wants to build your next board and also a relationship. Go check out screamingcircuits.com/the Amp Hour and go get an instant quote for your next board assembly. And now back to the show. I feel like we should, so we've got, we're 45 minutes in here. We haven't really even talked about all these. Damn, Ben, like how many videos have you made since since we last talked? There's so many here, so we got to talk about some of them. I'm just gonna go by sort sort by popular and look at
Oh, good,
some of
good.
the
This
ones.
this will be
Yeah.
telling.
So number
Yeah.
one is electron microscope slow motion vinyl LP. I was actually thinking about that because I got a new toothbrush the other day, and I actually don't think about the vinyl LP. I think about the toothbrush that you showed, and like the difference in the bristles and how they were super worn down on old toothbrushes. So what was that video in the first place?
The vinyl LP was me taking like a record and putting a phonograph needle on it inside a scanning electron microscope, and then animating it. I mean, it's basically stop motion animation to show kind of the needle riding in the
Yeah.
groove. That was a really fun video to make. And in fact, coincidentally, just last night I was editing more scanning electron microscope animation
Mm.
footage. So that'll
Oh,
be
that's
coming
great.
out pretty
That's great.
soon.
Yeah,
Yeah.
I really liked that. Didn't you create your own extraction system for the scanning electron microscope as well?
Yeah. In its current version, it's just a teensy with what's basically just a teensy that steals the bit stream and puts it into the computer, so I can just digitize the image quickly. But I really should do an honest, like a full on EE project for the channel, because I need a much better capture system, like a full on, like probably FPGA driven sort of capture
Yeah. What
system.
are the limitations with it right now?
Well, basically my skill level.
Oh no, sorry, I meant of the
So
actual like. Is it like capture time of like getting? Is it like slow scan for the actual getting the bit stream out, or what does it look like?
yeah, yeah, it's literally just an ADC with a USB port
Oh,
on
okay,
it,
yeah.
and so it just pulls in this thing. And so the challenge is that the machine runs on its own, and you just have to wait for it. Whereas what would be nice is if the computer could control the machine, then you wouldn't have to wait for it, and you could do much better things with frame
Got
timing
it.
and
Got it.
stuff.
Okay. Okay. Next up is a refrigerator that works by stretching rubber bands. This is actually somewhat low tech, but I think this was about the heat, or sorry, the cooling that happens from the mechanical properties of rubber bands, right?
Yeah, it's a cool thing to play with, right? Like if you're at your desk with a rubber band, you can stretch it and it gets warm, which doesn't seem surprising. I mean, you've put effort
Yeah.
into it. But if you keep it stretched for a minute and let it kind of cool back down to room temperature, when you let it go, it actually gets pretty noticeably cold. Like you can put it up to your lips and feel that it really gets cold when it
Mm.
contracts, which is really counterintuitive. I don't think most people would expect a rubber band to get cold when you let it
Right.
go.
Exactly. And then you like set it up so you had like a couple of them to create the heat extraction element from a actual a box, right? You created.
Yeah,
Mm.
exactly. I made the box. That was that. So that video was, I mean, I wouldn't say built for the Shaper, but this handheld CNC router thing that I like a lot. Um, but basically making all these flat parts out of plywood and cutting them out was kind of the sort of the thing that launched that whole video.
Yeah. Yeah. That's Jeremy Blum, former guest of the show, has been. He's still there, I think.
Yeah,
Yeah.
exactly.
Yeah, they've been. I think they're selling. Are they selling those in like Home Depots yet or no?
Oh yeah, yeah. I think Woodcraft is their chosen brick and mortar.
I don't. Is that a California chain? I don't actually know that one. Then again, I'm not really, wood crafter.
Yeah, no, it is definitely a chain around here. I thought they were national, but I'm
Hmm.
not sure.
Could be. I'm in like downtown Chicago now too. I'm not a lot of home goods or home repair stores here. So
No.
that'll do it too. Uh, okay. And then the next one is drill through anything conductive with an that says electrical something something. What was that?
Well, the EDM.
Uh, that's pretty cool.
Yeah, that was another one that was sort of like launched by a thing. And so this gentleman in I think the Netherlands builds these EDM power supplies and said, "Oh well, you should have one of these on your channel and show everyone the possibilities of EDM." And so that turned out to be a lot more work than I was thinking. Like basically, this guy has built the power supply
Uh huh.
only, but the whole machine and the control and everything is essentially someone else's
Hmm.
deal. And it was still a fun build, but it definitely took a huge amount of effort to put together the basically a entirely custom CNC control and the thing and getting it all working
Hmm.
and stuff. And yeah,
Yeah, yeah. It's not trivial, right? What was special about the power supply though?
it is a very high frequency, I believe, current controlled, very high current pulse current power
Oh,
supply.
okay.
And so I think it involves like a custom wound transformer and stuff with feedback, and it's not a trivial piece of
Yeah, yeah,
engineering.
definitely. Okay. I'm going to skip ahead because I have videos that I like of yours as well. And actually, it's not, I'm not sure why it's not higher up on the thing. Maybe because it's specialized. I'm trying to see where it is here. But the one that I always talk about with your channel is the laser traces. You're sorry, you put conductive traces on a thing. I don't remember what it's called. But you're basically making circuit boards.
Yeah, so that's actually an example of what cooking without a recipe looks like. So I always mentioned that, a lot of the things I do on my channel are either replicating papers or showing like a well-known scientific principle or doing like a demo or something. But the making conductive traces on plastic was a completely improvised, homegrown, no recipe type exploration, where I basically wanted to come up with a method to take a standard CO2 laser cutter and a standard piece of plastic or 3D printed plastic and put them together with some chemicals to make copper wherever you hit the surface with the CO2 laser. And there's a little bit of precedent. I mean, the whole technique exists in the commercial market, but no one's ever done it with like a CO2 laser with home chemicals and everything.
This is Andreas Spiess had like helped with the early stages of that company as well, the one that you were talking. So when he was on the show, it was like right when that video came out. But Andreas like was part like I think early investor or something like that. I forget. He wasn't a founder, I don't think, or I'm probably messing this up too. But he was somehow involved, and it was like it had just come out, and he was on the show, and we are like, wow, that's crazy that was kind of tied together. But this is like the when you go to a trade show and you see traces printed directly on plastic.
Exactly. Yeah, the commercial term for it is a MID, I think metallized interconnect device is the phrase
Yeah.
they like. And it's true. Andreas was I think, yeah, a founder, early investor, or something in the biggest, basically the industry leader in this tech. I actually ran into him at SuperCon, and it was good that I didn't like. I I was good. I didn't say anything bad in my talk about the this company being of being so difficult to prototype and stuff. But yeah, it's.
I'm sure it's fine. I'm sure it's fine. um, yeah, and the reason I actually mentioned is you'd think it would be because of the output, but I've actually never seen any product that's actually used this technique. I'm sure it's out there, right? It's like for antennas inside of cases and similar kind of things. I've actually never seen any usefulness out of it. The reason I like it so much is actually because you didn't have a recipe. Because the thing I always think about is you were up on the camera and you're saying, well, on try number 66, it started to work, but on try 88, that's when it actually worked. And I was watching that, Ben, and I'm just like, holy shit, you try that 88 times, and that's what I always point to is like the scientific method that you kind of employ on a regular basis, especially in your home shop. That like that's what I'm very very impressed with. So like, what does that look like to maintain that control and that discipline when you're doing like home experiments?
Yeah, it's I mean it's a lot of boring work. Or was that quote from Thomas Edison where he's like, success is like 1% inspiration, 99% perspiration or something like that. And it's totally true. I mean, I think a lot of people get the wrong idea about engineering or science where they think, oh, you must sit down and think about what you want to do and then you get up and then do it. But I mean, that doesn't work that way in any place of the world. It's tons of like beating your head against the wall and stuff. I was tutoring someone else about technical stuff, and she was so surprised that a lot of it is just literally beating your head against the wall until things
Right,
start working.
right.
Like that's the skill that actually makes it happen, and that's kind of the secret to it. So yeah, that process of trying things over and over is just a lot of boring work. Basically, just keep trying things, and they aren't random guesses. They're hopefully informed guesses, but they are in fact just
Yeah, so
guesses.
I just finished the book Grit, and it sounds like that's uh, kind of what they talk about in that book of like just like you need to stick with it. But what makes you stick with it? I guess I know these are kind of impossible questions, but like what drives you, Ben?
That is a really, yeah, so it's something I think about a lot. I mean, basically, motivation is the thing that underpins literally all of the decisions you'll ever make in your
Right.
entire
I mean, I
life.
always say that like if you have so I once replaced the center console in my car in my like Honda Civic, like really crappy car, or not a center console, the radio. But like I didn't know what I was doing. I broke a bunch of stuff, whatever. I eventually got it to work. And I had this thought of like if I had enough time and an internet connection, I could friggin' build anything. Now, is that really true? I don't think so. But like, with enough time and maybe add money in there too. And like you can really build a lot of things. Uh, but what makes you keep going?
Yeah. Well, it is kind of hard to put your finger on. Some people, what drives people to become these CEOs that basically spend, 80 hours a week really, really just driving a company hard. Like in a lot of cases, a company just won't be successful unless there's someone in there totally 100% dedicated to it. And you'd ask, why would you do that? Like, even if you're already financially stable, or if you're, or you don't care about being rich, like, what is it in fact that's causing you
Did you
to do
just finish the
this?
Elon Musk biography too? Because I just listened to that.
No, actually, it sounds pretty. I'd be curious to know what his
It sounds like he's
motivators are.
crazy, honestly. I respect what he's built. I mean, it sounds like he's terrible to work for. But like it sounds like he's crazy. Like that's like the best I've got. And like, God bless him. But so Ben, are you crazy?
Yeah, it definitely takes a little bit of it. Like, why would you do the same thing
Yeah.
88 times when there's no like financial benefit or really any other kind of
But
benefit or
I'm
something?
awed by it though too. Like I'm really like it is a sense of like I'm awed. So it's just because you wanted to get it done, I guess.
Yeah, maybe it's almost like the alternative is to just, I don't know, to like do something that's not as good. Or no, like the alternative of like watching TV or
Oh,
something. It's like, well, that almost seems worse in my
yeah,
book.
yeah.
So then it's like, okay, should I just sit around and watch TV today, or should I do the thing 88 times? Well,
Yeah,
okay, I
no,
guess.
that's a great example,
So
right? And I mean, what happens when you get something right? Do you get like a rush?
yeah, a bit. Oh yeah, well, especially in that case. So I mean, imagine cooking in the kitchen, right? If you throw random stuff together and it comes out tasting great, I mean, that's everyone's happy
Yeah,
about
but that's
that.
like your
And
tongue telling your brain to be like, oh, dopamine time, yum 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 yum.
actually, that's an interesting distinction. So yeah, it's true that food is a primary pleasure, and so all these other things that we're talking about are secondaries. Which, yeah, that's interesting
Well,
distinction.
yeah, I mean, I guess you could go. You could always go and trade your knowledge of laser sintered electronic traces for food, or you know, money or fame or whatever. I don't know what they're all secondary things, though, right? It's like food and reproduction are the two main things. So, uh,
Yeah,
mm,
exactly. And it's true. In fact, even on Hacker News today, Tim Ferriss, the creator of the 4 Hour Work Week, was explaining why fame is actually pretty lousy, and he goes into detail about all the bad things that have happened to him since he's become famous
yeah.
and stuff. And there was a funny quote from Bill Murray, he says, "Well, if you think you want to be rich and famous, why don't you just try being rich first and see if that takes care of what you need?"
Yeah. Yeah, no, I believe that. Uh, it's tough to listen to people say that though too. It's like, oh, okay, well, I get it. You're probably right, but come on, like nobody actually has any sympathy for them. You know what I mean?
No, and it's funny how that works. Like I definitely enjoy, having a big YouTube
Hmm.
channel. I'm not going
Yeah,
to lie about that. But it is also true that people may not quite see that there is a balance to it. And I think well known in a niche circle is probably the best thing. Like I could see Bill Murray like not being, excited about being
oh yeah,
recognized at a
yep.
restaurant or something. But if you're, a star EE guy or whatever, I think that's probably okay. And you don't have to worry about being recognized at a restaurant, but you still get the benefits of being well
Well, I
known,
don't know about your circles, Ben, but when you hang out at the EE restaurants, although I guess like once a year at like a post Maker Faire party or whatever these similar kind of maker, SuperCon or something, then it's like it's like Ben Krasnow's like the Bill Murray of SuperCon. So
Maybe so. Like I say, I'm not unhappy with it.
yeah,
I think
no,
it's
I think
fine.
and it's great to be able to like meet new people and like have people talk like understand like have a shared context, right? Like you have done all these projects, you've shared them, which is fantastic. I've benefited, a lot of people have benefited, and at the end of the day, it's like you can talk about a thing that you don't have to be like, well, let me tell you about everything I've done because they've already watched what you've done, and that's kind of nice. And then you can just kind of talk about the end result or what might be possible with it after the fact.
Yeah, I always try to get ideas from
Yeah.
people too. I always really enjoy hearing people's ideas for the channel and kind of what they'd like to see and
Yeah,
that sort of
yeah.
stuff.
No, it's great, and I actually do like that you read the comments, and it seems like you have a good YouTube comment section, like relatively calm.
Oh yeah, it's fantastic. In fact, I don't even know, like I don't police it or anything, but it just stays good all by itself. I'm not really even sure what happens, but yeah, it's a fantastic
Yeah,
comment
that
section.
helps a lot. It helps a lot. You mentioned food. That's another one I always bring up. I don't know why people don't bring this one up more, but like the cookie one, the cookie machine that you built is like one of my favorite videos of yours. Mostly because it's like It's like the
Oh
perfect.
yeah.
Anytime someone like brings anything about like, oh, we should like tweak this parameter, that parameter, I'm like, oh, it's like a design of experiment. Let me tell you about a video that's a perfect example of a design of experiment. It's about cookies.
Yeah, yeah. I think this one was actually inspired by a long time ago. There was or maybe it's still going. There was a conference called Exceptionally Hard and Soft. Kind of a
Uh-huh.
funny name, but that was its name. And there was either a mate or a beer that was varied batch to
Oh,
batch. And there was either a QR code on the bottle or some kind of identifier where you could know like which
yeah.
batch you got and vote on which one was your favorite. So that was like the seed that planted this. And I thought, well, I'll microize it down to like, the single cookie level as opposed to the batch of,
Right.
mate
Right.
or whatever it was.
Yeah. I mean, how much mate can you drink? You'd just be shaking out your boots.
Well, I think this was actually a commercial or at least a semi-commercial
Oh,
enterprise that was
really?
doing
Okay.
this. So they were making batches fast enough where they could have a different recipe every week
Oh,
or whatever it
that's
was.
kind of a that could be hit or miss. Like commercially, it's like, oh, well, this one tasted like a shoe.
I know, and yeah, exactly. And it's like the Coke experiment, where it's like, well, once people like
That's
it, they're
right.
probably not going to
Yeah,
stop
that's
liking
true.
it.
And
So
I
yeah,
mean, that kind of
that's
goes back to the whole product research thing. I mean, like you ask someone what they want, they're like, oh, I want exactly what I have. Don't change a thing or change something, and they're lying about what they actually wanted to change. It's tough to in the innovation space. It's like tough to ask people what they actually want in a new thing.
oh yeah, it's in fact it's the worst thing
Yeah.
ever. In fact,
Right.
unfortunately.
Yeah. Let's see. One other one that I really like. This is actually one you talked about at SuperCon was the electroluminescent display, and it seemed like that was pretty spicy to work with too because it was like really high voltage, right? Or you kept blowing up converters.
Oh yeah, yeah, I did blow up a lot of chips. That's right. Yeah. That was another case where, well, let's see, what was the core problem there? It was, oh yeah, it was that the data sheet did not accurately spec how much current. Oh yeah, that's right. So there were supposed to be protection diodes inside this high voltage control chip, and so it has like 60 push-pull
Oh
driver
yeah, right.
outputs, so you can get high voltage on the outputs, and that works. But they also spec'd protection diodes so that if there was ever anything below ground or above VCC, it would just shunt the current off like it should. And either the diodes were not present or they just had very very low current like super low current handling ability, because I had some cases where there was like an inductive
Oh
kick
yeah, right. So
and
it spiked up.
the voltage was going, yeah, it was either going above VCC or below ground or something, and it was causing the chip to instantly blow up. And when the chips died, they would also take everything out down the line, all the way through the signal path back to the
Yeah, that's so
micro
fun.
even. And it was one of these things where it was like you turn it on, it would be working, and then the whole thing would just die. It was like, well, that's it. And so then you have to rebuild the entire thing to even get one chance at seeing what
Right,
happened.
right. That's
So that took a while to,
yeah. I
yeah.
remember so you gave a SuperCon talk about that too. I think right.
Yeah, that's right. Yeah.
It's been so many experiments you've done.
Like,
So yeah. Uh, what are you working on these days? Like what is upcoming on the channel? And you're not allowed to say that Verily told you can't talk about it because this is you. So you're allowed to give a little hint here.
it's true. Yeah. Oh, yeah. No. So the this scanning, for EE projects, I really should build this electron microscope control, because just yesterday I was collecting another animation with it. So I have these carbon nanotubes. The Vantablack is basically a forest of carbon nanotubes standing
Yeah.
up vertically, and there's this weird thing where if you pull on it, it starts unraveling like pulling a thread out of a sweater. It's kind of weird. You can actually pull like a mile of carbon nanotubes out of a little square centimeter of forest of
Wow.
nanotubes. And it's weird because they self-align. Like if you basically tug on the string, this whole random looking carpet becomes a thread sort of
Hmm.
automatically. And the process is weird. Like, why would that even happen? So what I did is I got scanning electron microscope animation, stop motion animation of this uncoiling and threading process happening like right at the junction where
Wow.
it's going
That's
on.
awesome. How did you instantiate
I,
the pull for that like is it like a stepper motor or something?
I did it by hand. So this is the thing. I'd like it to be a stepper motor, and that's the next generation. But no, I sat there for an hour and just twiddled the knob by a couple
Oh
microns
my.
every time. For each frame.
Did you have actuators inside of the SEM? Is that right? Like how do you actually grab the thing?
There's a couple of knobs on the outside, and it's just a micrometer, and so you just twist the knob and it moves the stage on the inside.
Yeah, that's just like that's kind of a good example of like the boringness of science sometimes is just twiddling the knob little bits at a time, huh?
Oh, I literally sat there for an hour and a half, just turning a knob by like a tenth of a turn every time the frame was done.
what
Yeah, so that's what it takes, you know.
Science. Oh man,
Yeah.
that's great. That's great. Other like chemistry type things that you're doing, or what else is on the chemistry side of things? How many like concurrent things do you have going at once? I guess.
Kind of maybe about 4 or 5 or so. Some are sort of back burner. I actually do have another interesting EE project. For blind people, they want like a tactile tablet, like basically a tablet computer
Oh,
that has a physical display with like little pins that
yeah,
raise up and down. And a few companies have kind of worked on this a little bit, but I was looking for something like way more like impressive, like bigger. It's like currently, like the state of the art is like piezo actuated plastic pins that move up and down by
yeah.
like a millimeter. You know, it's functional, but maybe it's not really that impressive. What we'd really like to have is almost like a pixel display, like a full on, like, you know, 1,000 by 1,000 pixel display of like physical pixels,
Yeah.
basically. And the way I'm going to implement this is by using Peltier junctions that heat up or cool
Ooh.
down, and then you put like a bubbly, like a soft chamber filled with a low boiling point fluid on there, so that when you boil it or contract it, the bubble basically expands or contracts, and it should be very
Yeah.
fast,
Oh
like
wow. Okay, that's
milliseconds.
exactly what I was going to ask about, because I would imagine like it would have like a rise curve and a fall curve, and you'd have to drive it both ways, I guess, right?
Yeah, exactly. And it's kind of an interesting, it'll have a fair bit of like interesting EE work, and then also this boiling point
Hmm.
fluid and everything, which I know which one I want. It's just hard
Ah,
to get.
got
And
it,
so
got it.
yeah.
Yeah, what is your source on some of the stuff that you get is like some of it's eBay, it seems like, but some of it seems like you're not like making deals in like Twin Pines shopping mall parking lots, are you? At like 2 in the morning?
No, I wish I was though. I mean, those deals are, I mean,
That's
those are
true.
hard
That's
to
true. You
come
get the
by,
good
but
stuff then.
yeah, no, I think it's annoying where companies are like, oh, well, we're not going to sell to you because you're not a
Uh,
huge company or whatever. Everyone's just so worried about
that's
liability
true.
these days. It's kind of
Yeah.
ridiculous. You'd be surprised what you can get on eBay and other sources though, and some of it is like
Yeah.
repurposing too. Like I got a great example. Very recently, I needed a source of radioactive material,
Okay.
and they made these static brushes for cleaning records, phonograph records, back in the 60s called the Static Master. And people that like these brushes like them because they actually have a radioactive element in there. And the radioactivity causes you to ionize the air, and it actually discharges like static cling. Like it gets rid of static cling inherently just because it's emitting
Wow.
ions. And it's very active. It's actually 500 microcuries of
Oh my
polonium
god.
210, which is the same substance that the Russians used it to kill their spy back
Yeah,
in
yeah,
London.
in the
Remember
tea,
that was a
yeah.
few years ago.
Right.
This,
Oh my god.
and 500 microcuries is probably more than enough to kill a person. And so it's very well like contained within this metal matrix. But if I wanted to get banned on YouTube, what I would do is show how to extract the polonium from one of these sources.
So if Ben disappears if Applied Science is no more on YouTube, we've found out why.
That video would
Oh
definitely
yeah,
get
yeah.
taken down. So that's I
Yeah.
know
Yeah.
not to do that, but it's still fun to play with this polonium source. It's incredibly hot. 500 microcuries is
Just imagine all the safety comments you're gonna get on there. Ben, your fingers are gonna fall off. You're gonna need a robot finger at some point.
yeah, exactly. I know. I
Oh, that's
love it.
great. And what is the radioactivity for? Is it just some unknown thing yet?
Well, well, it's a
Got it.
secret
Secret.
project at work,
Okay, that one. I'll give you
unfortunately.
that one. You know what? That radioactivity. We'll give you a secret project on that one. Oh, that's great. Well, Ben, thank you for coming back. I can't believe it's been 8 years. Let's try and make it less than 8 years next time.
I
That's
know, that's
way too
crazy.
long.
Yeah.
I'm very grateful that we get to hang out at some conferences. What are some conferences you hang out at if people want to maybe hang out with you?
SuperCon for sure. SuperCon's the only one that I basically go to regularly. I probably should start doing more, but I don't know, the current work schedule and everything. I think SuperCon is the one you can
Okay,
always count
great.
on at least.
Maybe KaiCon in 2020. We'll see.
Yeah,
Yeah,
actually, maybe so.
it's in
What month
September.
is
So
it?
the 11th, 13th, yeah, 11th to
Okay.
13th. It's in Switzerland, but come on. I mean, it's CERN. Like, that's so cool.
Yeah,
Yeah,
September sounds pretty
okay.
good. No, that's good.
Where can people find your stuff online if they don't already know?
You can search for Applied Science videos or just Applied
Yep.
Science on YouTube.
Great. And support him on Patreon. It's a great Patreon and supports direct science. That's great. Thanks, Ben. Thanks for being on the show.
Yeah, thanks very much.